Version 12 relies exclusively on INI files to store settings. It also uses INI files to save data for exporting and importing. To avoid problems with formatting and default characters, when using different regional settings in Windows, version 12 forces all programs to use US-centric settings, as shown in the information on the screen.
Welcome to this tutorial on how to use MPO Canopus to do time series asteroid photometry. It will cover producing the data for light curve period analysis, but not the analysis itself. A separate tutorial goes through the steps of using the data from this tutorial to find the light curve and rotation period of the asteroid. If you have not created the tutorial's user profile, you must do that before going through this exercise. The profile you create is used in many other tutorials. You'll find it on the MPO YouTube channel. And if you haven't already viewed the tutorial on the image form, you should also watch it before going through this exercise. It gives an overview of a form based on a template that you'll see many times here and in other MPO programs that display its images. To save time, it's assumed that you're familiar with the image form basics and can concentrate on the steps required to generate data.
While you may be working with the same sample images that were used for this tutorial, you may not see everything exactly the same. For example, when selecting comp stars, you may get a different initial list of candidates. Do not let this get in the way of following and understanding the steps. If the tutorial says to use comp 8, but it is comp 1 on your computer, don't worry if the two stars don't have the same numbers and may even be different stars entirely. It is the process, not being able to get exactly the same results, that is important. Obviously, if any differences have a significant effect on the final results, then go back to the first step where things went wrong, and see if you can see what happened. Anytime a directory path is mentioned, it will be assumed that the version 12 directory tree is off the root of a drive, for example, c:\MPO v12. Anytime a path is referenced, it appears as just MPO v12, for example, MPO v12 \, and then the rest of the directory or file path. It is also assumed that you did not change any v12 subdirectory names, and that you downloaded the sample images used in this tutorial.
Here are the main steps for measuring the images. Reviewing the images allows those with less than perfect mounts or guiding, and who are sure that no clouds roll through during the night, can just load the set of images. The image paths, not the images themselves, are stored in memory. The rest of the steps will be very familiar to those who use version 10. Either way, though outdated in some ways, the version 10 Canopus manual and user's guide remain useful resources. Let's presume that you want to look at large thumbnails of the images to be measured. Set the Review switch to Review. To make things go faster, set the Use Process Frame switch to No. Otherwise, any preloaded flat, dark, and/or bias frame will be applied to the image buffer of each image. The inclusion of the processing frames is in memory only. The original images are not changed. Set the scaling switch to Compressed. This is the standard compressed scaling used in version 10 of MPO Canopus. If you have images with some moonlight interference, then using standard might be better. This setting will also apply to images after the Review tab. Depending on the size of your images and resolution of monitor, you can choose a default size scaling. In this case, 75% allows seeing almost all of the 1K by 1K images. Set the measuring apertures to be used for measuring the images. Set the every X images number to 1. If using a subset of a very large set of images will still get the data you need, set the number to, for example, 3. In that case, images 1, 4, 7, etc. would be loaded into the images list. Click the Flat button. Navigate to the directory shown here and load the flat file. Click the folder to open a multi-file select dialog. Navigate to the path shown here and select all the files in that directory. In a case where every X images is greater than 0, you still want to select all files between the first image to be measured and the last to include the overall set. The program will split the list as needed. Click the OK button on the dialog to start loading the images into the reviewer. If you want to stop the loading, click the Abort button. If you don't like the final results, you can delete all files from the list by clicking the Trash Can button and then selecting the Folders button again. Once the images are loaded, scroll up and down the screen to find an image to be skipped, if any. Click the green check mark to exclude an image. The button changes to a red X. Double-click on an image to show a larger version to help decide whether or not it should be included.
To select a range of images to exclude, click the check button in the first image, and then Ctrl+Shift+ click in the last image to be excluded.
You can click on another image further down without affecting the range you just created. Once you have selected all the images to be measured, click the Accept button to process the list and go to the Image 1 tab.
Before loading the first image, some settings need to be made. Check None in the search box. This means the program will try to find, if it can, the one and only one asteroid from the FITS header. The Find button would find all asteroids in the image brighter than the value in the MAG field and with a maximum value greater than the number of sigmas in the field. The List button would show a form where you could enter one or more asteroids, one line at a time, that you believe are in the image. It will scan the orbital elements file for those objects only, which will take considerably less time than the Find method. Set the 0 flag only switch to No. If set to Yes, then only stars with a 0 flag value in the list produced by Sextractor will be examined. This can be useful if there is a bright globular cluster in the field. In the Session Photometry box, set the catalog to Atlas. For asteroid photometry and astrometry work, this catalog is strongly recommended over the other supported catalogs. The astrometry is from Gaia Data Release 2 and includes proper motions. The systematic errors for the Pan-STARRS magnitude bands are very small. They are larger if using the BVRI magnitudes. A clear filter was used for the images used in this tutorial. Set the MAG band to PR, which indicates the R band on the Pan-STARRS photometric system. Please note if you set the filter or MAG band after you auto-matched image 1, you'll get a message about needing to reload image 1 so that the auto-match extracts the correct magnitudes from the chosen catalog. Set the color index band to VR for now, and set the CI value to 0.45, which is a good default V- R magnitude for asteroids. These aren't actually used unless you apply transforms on the fly, but selecting them helps create an accurate sessions record. Now click the Load button. After a few seconds, the image will return showing the path of the target asteroid, and others if Find or List was used. The available asteroids list shows all the asteroids that were found. Since there is only one, it has automatically been set to be the key target. If there is more than one target, and you want to measure something other than the one found by auto-match, you would click on that target in the list and click the Key button. An asterisk appears next to the key target. Should the automatically placed apertures be off the asteroid because of timing error or older orbital elements, click on the target on the image, and then click the Recycle button. This prompts you to confirm the update. Click the Accept button. This registers the selected key target and goes to the Image 2 tab. Do not click the Load button on that tab at this time. In the Session Mode box, select the New Target and Comps button. The New Target Previous Comps button would create a new session. You would then select a previous session that used the same comps to be used for the new session. If you have target that is in the same field for several nights, this can make things easier. Add edit would not create a new session. Instead, you would have to select an existing session. Any existing measurements will be overwritten, new ones will be appended to the session. For example, this would be used to remeasure the image using a different flat or different sized apertures. If the purpose is to change the comp mags from one mag band to another, still using the original catalog, use the Sessions Manager program. Do not enter a value in the name field. This is used to override the assigned session name if measuring a target different from the one defined in the FITS header. Confirm the values in the remaining fields and match the values shown here. The value of G can be changed from the default at this time. This affects the phase angle corrections when doing light curve analysis. You can also change it when doing the analysis. Click the Load button to load the last image in the selected list. It will be matched automatically. A common targets form should appear. Depending on the option on the Image 1 page, it may show only one object or several. In this tutorial, there is only one target. Had there been more and you wanted to use a different target, click on it and the numbers and plot will change. This alternate target must have been set as the key target on Image 1. As on the Image 1 page, if the apertures are off a little, click on the target on the image and click the Recycle button. Click the Accept button if ready to move on. Click the Accept button under the list of targets. In this case, a new session is being created and so it may take a few seconds, and the form may go black. Have patience.
The form should set itself to the session page. The new session should be highlighted at the bottom. Review the values in the fields to the right of the sessions table. Click the Accept button at bottom center. This takes you to the comps page. The min SNR value overrides the default value from the configuration. In this case, set it to 25. The SAT percent value is the percentage of the maximum possible value given the number of bits per pixel in the image. For example, a 16-bit image has a maximum value of 65/535. With this value at 60, the maximum pixel value for any of the potential comp stars must be less than 39,231. There are several reasons for setting the value to 60. If image 1 is at higher air mass at the start of the set of images, that is, close to the horizon, the comp stars will get brighter as the field rises higher above the horizon. Using stars too close to the saturation limit at high air mass could easily allow the comp stars to become saturated at low air masses. The other purpose is to avoid using the brightest stars every time. It's been shown that it's better to use comps of about the same magnitude as the target, maybe a little brighter. This and the minimum SNR settings are somewhat interactive, so a valid value in one may lead to problems for a given value for the other. Set the minimum number of comps to find at 3. Of course, more would be better. The maximum number of comp stars allowed in version 12 is 15. Don't set the number too high. The field may not have enough valid candidates. Since we're working on an asteroid, check the solar box to limit stars of near-solar colors, which will match the approximate color of the asteroid. Click the Select button. After a second or two, all potential candidates are enclosed in an orange circle. In addition, some of them are numbered and appear in the comp star list at upper right. Do not click Accept at this time. You need to review the selected comp stars.
If all the numbered stars, especially Comp 1, aren't too bright and don't have close companions, click the Accept button to move to the Star Be Gone page. That is not the case here since one of the stars is actually a galaxy. Click on it in the list. An aqua-colored circle should surround it. Click the minus button under the comp star list. The galaxy is no longer within a circle. The list has been updated by moving all the items below the galaxy up one place, and the numbers on the image have been reset. Above all else, the Comp 1 star cannot be too bright nor can it have a close companion. The simplest way to assign a new comp 1 is to click on comp 1 in the list and then click the minus button under the comps list. The star is removed from the list and image. If a message about there being no comp 1 appears, dismiss it. There are now less than 15 stars in the list. On the image, click on one of the unnumbered solar-colored stars that looks to be a good comp 1. Click the plus button under the comps list. This adds the star to the bottom of the list where it is highlighted. Click the key button. The new star and original comp 1 swap places in the list and their numbers are updated. Continue the review process, eliminating other stars with close companions or that are too bright, replace them with better suited stars. Once you have a good list of comp stars, click the Accept button to go to the Star Be Gone page. This may take a couple of seconds while the program updates and saves the selected comps to the active session record. It is not required that you find SBG candidates. If that's the case, set the Use SBG switch to No and click the Accept button. In this tutorial, we will select SBG stars, so the switch is set to Yes. The Mode button determines what happens when a Star Be Gone star needs to be handled because it's close to the target. Set the switch to Sub. The program will subtract the star from the measurement. If the switch had been set to Skip, then any image where an SBG star is too close to, or involved with the target, is bypassed. Click the Select button. After a few seconds, you should see the asteroid path in aqua color, and a number of stars, some very faint, surrounded by red circles. Those are the SBG stars. If the asteroid moves far enough between image 1 and image 2, then image 1 may not show all the SBG stars. Click the To Radio button to see the stars on image 2. Now click on the Image 1 button. The position of the asteroid on image 1 is indicated by a square. There are a number of stars to the right of the path. In other words, they will never be approached by the target. Set the sort order to X, that is, by X values. By moving the mouse over the image, you can see that the XB value changes. It is the actual position in the image buffer. The XS value is the position on the binned image, or, if it is being displayed at 100% scaling. The two values, and their Y value counterparts, will be the same if the image is binned 1 by 1 and displayed at 100% scaling. Scroll down the star list to a star that has an X value that is a little larger than the one for the aqua square. Click on it in the list. An aqua circle surrounds the star. If it is not fully to the right of the square, go further down the list. Repeat until you get to a star that is fully to the right of the square. Without clicking on the list, scroll to the bottom and press Shift plus click on the last star in the list. Click the minus button below the list to remove the selected stars. Once you have an acceptable SBG list, click the Accept button to go to the Measurements page.
Set the TO or timeout field to 30, which means the maximum time allowed to automatch an image is 30 seconds. Set the delay to 0. There will still be about a 6-second delay after measuring an image and loading the next image. If the value is other than 0, the program will pause value seconds between images. The C1 reset switch determines what happens if the comp star moved too far from its position in the previous image and needs to be relocated. The auto option means that the program will do an auto match to find the comp star. The man option means the program will prompt you to relocate comp 1 by clicking on it in the image and then to confirm that choice. It will do this anytime comp 1 cannot be found. Set Redo to Yes. This means a duplicated observation, that is, one that is within 1.5 seconds of an existing observation, will replace the existing record. If set to No, the new data will be ignored. Click the Load button. This automatically loads the images you accepted or loaded without review on the review page. It is not necessary to select them again. Set the auto switch to Yes. This means that after the program measures an image, it will automatically load the next image in the list. If set to No, You will have to press Enter on the keyboard at the appropriate time to load the next image to be measured. Click the Use Target Aperture box to use the target aperture settings. Otherwise, the comp star apertures will be used to measure the target. Click the Measure button. The program should go through the list image by image, measuring the comps and target and storing the observation for each image. The items in the list are color-coded to show the result of trying to measure the given image. To toggle the coloring legend, click the flashlight button at the bottom right, immediately under the list. Once all the images are measured, click the Restart button. This reloads the form and clears all internal variables. If you try to go again without the restart, you won't be happy with the results. Assuming you want to measure the next set of example images for this tutorial, click the Clear All button. If you are going to measure the same images again, but for a different target, you would click Keep Review. Before you move on to finding the period for the asteroid, measure the images for the remaining 2 nights. This tutorial is long enough. Including the analysis steps would be information overload. It's time to take a break.
This concludes this tutorial for generating time series photometry data for an asteroid. More tutorials are on the MPO YouTube channel by using the URL on the screen. Please subscribe so that you will be notified when new tutorials are available. If you have any questions or comments, please send them to the MPO software forum on Groups.io. Please note, you cannot attach files to messages. If necessary, you will be asked to send them offline. Thanks for watching.